So the thing that can give us the signal that we are at the equivalence point or near the equivalence point is what we call an indicator. So an indicator is also an aqueous solution of a certain compound, and these compounds change color depending on the pH of the solution. A classical example of an acid-base titration indicator is called phenolphthalein. So phenolphthalein is clear, so it's colorless. It's colorless at pH less than 8. So if the pH of the solution is less than 8 and you added a drop of phenolphthalein into that solution, the solution will still remain as is. So it's because phenolphthalein is colorless at pH less than 8. But if the pH of the solution is greater than 8, then phenolphthalein is colored pink. To be more specific, it's fuchsia. It's a bit in the dark side of pink. So if you have a solution that is basic, then I dropped a solution of phenolphthalein into that solution, basic solution, you will see that the solution will turn pink. You can see a lot of YouTube videos on this. So now, let's relate this concept of indicator as to how it signals us to the equivalence point. So let's go back to our story a while ago. So we have 10 hydrogen ions in our analyte. Now this time, we have the presence of phenolphthalein in our analyte. So I will represent phenolphthalein with pH. So again, this is acidic, and we know that phenolphthalein is colorless if the solution is acidic. So this will remain clear. Again, we will slowly add the titrant sodium hydroxide, which will slowly neutralize the hydrogen ions. So one by one, your hydrogen ions will be neutralized. Now, as long as the solution is acidic, our phenolphthalein will remain colorless. So we add, slowly neutralizing the hydrogen ions. Now, at the equivalence point, okay, this is the equivalence point. We no longer have the hydrogen ions. At the same time, we don't have hydroxide ions in excess. This is the equivalence point. But this is still pH less than 8. So your phenolphthalein will still be colorless. But if we add a very little amount of our sodium hydroxide solution, such that, okay, just a tiny amount of the sodium hydroxide solution, such that the pH will slightly increase, okay? That slight increase in pH will cause this solution to be slightly basic, right? So what will happen? We know that phenolphthalein is color pink if the solution is basic. So if we have a tiny excess of hydroxide ions in this solution, then the entire solution will now be or will now turn pink due to the presence of the phenolphthalein, right? So it's now pink. This will be our signal. So this visible signal, which is the color change brought about by the indicator, is called the endpoint. Now the endpoint, in principle, should be equal to the equivalence point. But most of the time, the two are not at exactly the same point. Okay? So there is a very, very small discrepancy between your endpoint and your equivalence point. But as long as your endpoint is very, very near your equivalence point, then we have some degree of accuracy in our titration data. Now, what about the computations for titration? That is what we will discuss in the next video.